Hey, hello, and welcome to the show. It's me, John Park. It's time for JP's product pick of the week. And I want to thank you all so much for stopping by. Hey, Thin Man, thanks. Yes, I'm doing well. Hope you are too. Who am I talking to, you may ask? The chat right over here is in our Discord server. So if you're looking for the chat, head on over to adafruit.it/discord and look for the live broadcast chat channel. We've also got some people over in our YouTube chat. Hey, Dave Odessa and Tech of the World, nice to see you. And off we go. So we've already got some Photoshoppery going on. That was quick. Thank you so much for that. So I'm gonna actually, first off, point you at these URLs because we've actually got 3 discounted products. They're all related to each other this week. So if you go to these URLs, you can go to any of them. If you head to that QR code, it's kind of the main one. But this video plays from inside the product page. Just scroll down a little bit. You'll see some icons down there for video. And this show is happening right in there. And like the sign says, you get a big discount during the live stream. So we don't use a coupon code for this or anything like that. We don't extend rain checks. We don't back order things. We just say if you are here now during the live stream and you want to get in on the discount, I believe we have a 50% off on each of these 3 items. Probably a maximum of 10 on them. That's usually what we set it to. Just throw them in your cart and buy them. You don't need to do anything else special. Just get them for that good price. In fact, I'll double check that those are happening. They are, and we have a stock of these that we reserve for the show. People sometimes ask how that works. We usually have a stock of these that we hold so that we know we have a certain number of them before the show starts. Hey Liz, Blitz City DIY just showed up in the chat. So anyway, yeah, head to these URLs and QR codes to get a jump start on it. And the next thing I'd like to do is have Lady Ada introduce us to this product from her new segments. Please take it away, Lady Ada.
Product 292, a classic. This is our I2C and SPI LCD backpack. It got a huge update. I was going to update this to add STEMMA QT, and then I was like, while I'm here, let's kind of fix all the stuff that I wanted to update with it. So this is a backpack you solder onto the back of your 16:2 or 20:4 character LCD with a backlight, and it's just a very simple but very effective I2C or SPI, latched, it's a 595 chip controller. It basically means you just need 6 GPIO to control LCD. You only need 2, or in the case of SPI, 3 of them. And it just works very well. We have library code in Arduino and in CircuitPython. And this board's been around for so long that people have been using it, and there's lots of projects. So the new version is mechanically the same size, right? Like the holes are in the same place. Actually, I added another mounting hole because I made the parts a little smaller. But it adds, okay, so go over here. It's 2 STEMMA QT ports in the bottom and the right, because I wanted to keep the terminal blocks in the same location. There's a small on LED that'll let you know when it's powered. The thing that I like the most is that I've updated it to have a little boost converter. It now has a switch cap converter that will take the input and give you 5 volts, which means that you can run this off of 3-volt power. The previous version was 5 volts only. LCDs tend to need 5 volts for power and logic. Sometimes you can run them on 3, but if you want the backlight to be nice and bright, you want 5 volts. So this will boost the voltage from 3 to 5 for you, so you can use it with your QT Py or your RP2040. I also updated the contrast potentiometer to be a lot nicer. The previous one was kind of this SMT potentiometer, which they work and they're very reliable, but I wanted one that was easier to turn with a simple screwdriver. Other than that, it's the same design, and so you can use all the code that we've got. It's STEMMA QTFI, just easier to use, overall better.
Wow, that is a ringing endorsement. Overall better. So let's check it out. These are actually the 3 product picks that I've got this week, and I'll leave this screen like this while I say these are my product picks of the week this week. It is the SPI I2C LCD character backpack, as well as the 20x4 and the 16 by 2 LCD displays. So let's take a look at these one by one. So first of all, here, let me jump back to here. This is sort of the main boss here. This is the most important part. This allows you to connect to your microcontroller either with 2 pins using I2C or 3 using SPI and control your characters. We have nice libraries for Arduino and for CircuitPython that allow you to set things such as the characters, scrolling, moving them around. You can use special characters. You have up to 8 custom characters that can be any design you want. I'll show you a little bit about that in a second. And one of the really nice things about this is that it mounts to the back of the display. So here's a typical display. This board mounts to the back like that. And now you don't have to have your microcontroller with a bunch of goofy wires and terminal blocks and so on. You can actually just use a STEMMA QT connector, something like, let me take one apart here. Something like a QT Py plugged into one of those STEMMA QTs, and you're off to the races. You can use either a battery to power all of that, or you can use USB, is a pretty common way to do it. And then we have 2 different displays here. There's actually more than these 2 in the store that will work with this, but these are kind of the 2 that we recommend, and these are the ones that we have on discount today. So these are a 16 character by 2 lines, and this is 20 characters by 4 lines that you have. Both of these are reverse displays with white on blue, so there's a large LED element under there that's blue. And why don't I show you these, I'll show you in the overhead in a second, but I can show you, here's one in action. So you can see I've got a QT Py, I've got my backpack back there, and then I've got the display. The camera's a little bright here. Let's go to the overhead for that. And I can adjust my exposure down to something that'll look nice. So here you can see, bring that exposure up just a little bit. Okay, so here you can see I've got 4 lines on this one. I've got some blinking cursor, which is part of the library. Notice the J and P, those are a custom font, so I did a couple of custom letters. Same with that little sort of Space Invader guy who's flying along on the bottom there. It's a custom, so I filled 3 of the 8 custom slots, and then you can just call them using an address. Here you can also see I'm doing some of the sort of automated scrolling, moving. Here I'm using the little move right command, and then I'll run this set of text and then use scroll to kind of move that off to the side and rearrange that. And as Lady Ada mentioned, we now have on the back here a sort of smaller, nicer little potentiometer for adjusting the contrast. So I'll see if I can still have, yeah, we can still have a focus on that. So I'm going to take just a little screwdriver, put that in the back there, and you can see you can go all the way from this almost non-reverse look, which is kind of cool, and then in the opposite direction we can go about right there. It looks pretty nice. You can, depending on what you're doing, you can kind of get away with lower contrast and getting rid of those visible blocks, or you can just go full blown like that. So once you set that, it's pretty stable. So you can kind of set that and forget that and leave it like that. So that's the large one. That's the big 20 by 4 character display. One thing I did here with the board, you can see the board has, I think it's 16 pins here for soldering down to this fairly standard backpack set of connectors. You can, if you want, solder that directly on there and clip those and get a nice svelte display. You can also, let me adjust my contrast or my exposure a little bit. You can also flip it up like this if you're trying to go minimum thickness. So depending on what you're mounting this into, you may want to go, you may have bezel space, but you just want it to be really thin, like you're putting it up against a wall or something. This can go in that direction or that direction and buy yourself a little bit of extra space. You could also mount it from the top like that, and that would eliminate sort of any points on the board being lower than your display. You can also use a set of headers if you want some versatility, especially if you're prototyping. So I took our board, our little LCD driver board there, and put some socket headers on there. You can plug that in like that. Obviously that sticks out a lot more, but now you can swap that onto different displays for testing. In this example, actually, I've also hooked up a rotary encoder just to give a sort of pseudo example of a project. So I'm going to take Qt Py, which is plugged in over STEMMA Qt to my rotary encoder, and then I've got that plugged into the display, and now I'll give power to my Qt Py, and that's boosting that up to 5 volts. And let's let this start back up. Let me adjust my exposure there. Come in a little closer, and yeah, the focus looks good. So now I've got a couple of functions I can do with my little knob here. I can rotate that to move the text around. Oh, that's a little, let me take that exposure down. That's a little better. So I can move that text side to side with a fairly simple bit of code. I'll show you the code in a second here. I can also cut the LED so you can turn off the backlight. And depending on your exposure here, you can now use it as essentially a non-backlit, and it's an inverted display. We have both regular and inverted displays that you can use with this. So you can see, depending on your conditions, this may be what you want, maybe more legible, or you may want to go to the turn on that LED there. I don't believe we can control brightness from the library. But it's possible you could just PWM the LED from a different pin, but I don't think the library allows for brightness control, in case anyone was wondering about that. Here you can see actually also I have what I consider to be the minimum viable Adafruit logo, so I made a little custom character here, and I can call that from address 0, and it is the tiniest little Adafruit flower that I could draw in the essentially 5 by 8 pixel space that each character occupies. That's the size of those there. Yeah, so someone asked, the LCD screen needs 5 volts. Yeah, so the 3 volts is coming from my Qt Py over I²C, and there's a boost happening on the LCD driver board that brings that up to 5 volts for use by the display. So let's see. Before I go further, let's jump into product page here. So you can see we have, this one's product 292. That's a pretty early one. It's just been revised a whole bunch with this latest revision, also including pretty pins or not pretty pins, Penguin to use nicer looking silkscreen graphics on it and fonts. We've got the 2 STEMMA Qt ports on it, and also the new contrast potentiometer on there. If you want to get a display, these are the 2 that we have on sale today as well for half price. So there's the 16 by 2. It comes with a 10K trimmer pot that you don't need. Depending on, I think back when you were hooking it up on a breadboard to an Arduino or something, I think we recommended this, but you don't need that anymore, so that's just a little freebie that's in there. And you've got more than enough header pin there to plug that into the board. And then we also have this much bigger one, the 20 by 4. Get a whole lot of text on there with that big guy right there. And these have a nice sturdy metal frame around them, by the way, so the display isn't going anywhere, and the integrated LED backlight is underneath there. So it's all in one nice handy package there with mounting screws, so you can build that into a project. If you take a look at the Learn Guide here, let me find mine. This will tell you everything you need to know about the pinouts on the board. Take a look here. It tells you about the power, all of the I/O pins. Of course, you don't have to use STEMMA Qt. You can connect up over the wires. There are these terminal blocks that come with it, and those can be soldered right to the bottom of the board there, and then you can run some wires, stranded wires work best, and screw them in from your microcontroller. You could also solder to those points directly, or if you don't want to use I2C, you're not going to use the STEMMA QT port, you can go over SPI as well. And this board essentially has two multiplexing expansion chips built onto it. So there's the MCP23008, which is the expander for I2C. I think that gives you 8 pins. I think there's one free maybe. 7 are used for the LCD. And there's also the 74HC595, which is the SPI expansion pin. So both, or chip, so both of those are built onto there. If you want to use SPI, there's a jumper for that. If you want to use multiple of these boards on a single I2C bus on one microcontroller, we have address jumpers on it. Let's see if we have those. Let's see, we can do, I'm not sure what the maximum we can do on there is, how many boards you can run. But if you just look on the bottom, no, I'm lying, it's on the top, yeah. On the top of the board there are your I2C address jumpers, so you can switch that to a different address if you want. There's a little discussion here actually about which LCD to use. So one thing we do have there are RGB LEDs, or LCDs rather. So it's an LCD with an RGB backlight. This is a different model, I'm not sure which one this was. I've had this one just in a drawer for a decade probably. But this will work. So if we take a look here, let me go back to the down camera for a second. I'm going to go ahead and unplug this one, and you can see there's the convenience of having that on a header rather than soldered to it. And now I can plug in, this is an RGB LCD backlight. It has 2 extra pins that I clipped because I had them already soldered, just because we're not going to use those. These have 18 and the board has 16. So those 2 extra pins are for the blue and the green element. This board does not control RGB, just want to repeat that. So the RGB displays can be used, but you will need to run 2 spare GPIO pins from your microcontroller, so it's going to be a wiring situation up to those pins. That said, there are still uses for these. So I've got the first pin connected, which happens to be red. So if you plug an RGB board in like this, you're going to get a red backlight. Reset this board. Come on, you can do it. I'm not sure what is happening with this one. I say you can use these, and I promise I've been I've been using it, but this one has decided to fail. Let me pull the rotary encoder out of the mix there. By the way, we've got STEMMA QT on the bottom and also on the side, depending on how you want to plug that in. Oh, turn up the potentiometer. Thank you. Who said that? Tackle the World. Of course, it's the potentiometer, I bet. Let's see. So yeah, that's a great. Sometimes this is a really easy way to fool yourself. It'll look like your display is just straight up not working, and then if you adjust the pot, sometimes it comes to life. No. Let's see if it's still working with the proper display. It's not a good demo for the, hey, yeah, I promise it'll work with other displays. For some reason, it's not right now. I'm sure that's something I did. I didn't test it on this USB. Oh, no, you know what? It does look like I have done something terrible, probably to the code on this board. Let's, while things are still working, I'm going to plug this other one in without messing with it, just so I can show you a little bit of code on this one. So let's see. How's this one doing? Okay, so this one's still working. So I'll go back to that in a second, but since this is actually up and running, I wanted to show you the code for this. So let's see. If we jump to this view, give me 1 second to point this screen capture at the right thing. I was messing around with Wirecast before. And there we go. So I'm just going to open code running on the little cutie pie that's on that board. CircuitPy drive code. And so you can see here to talk to these displays. By the way, before I go any further, I did want to do a live protective film peel. Ooh. There we go. So if you look here, we've got the library Adafruit character LCD, importing that as character LCD. And then in this code, I was actually preparing it for running on both types of displays, the 20x4 or the 16x2. So I had a variable for this called isBigTrue, and then I have different things happening in code. I kind of abandoned that and wrote different code for that other one, so I don't know if we'll see that appear anywhere else. But the key things that happen are we set up an I2C bus here, in this case board.stemma I2C. And then I create an object called LCD, which is the character LCD over I2C. There's also a variant for SPI. And we feed it the number of columns and rows, in this case 20x4. And then if we check out some of the commands that we get, LCD backlight equals true. On that other demo, the one that's not working right now, I was actually turning that backlight on and off using the potentiometer knob. So you can do that while it's running. You can maybe do a little sleep if you're trying to do a low power consumption thing. You can shut off the LCD when it's not in use. These are some special characters that I made. So I made a check mark, a triangle, that little space invader, and then that J and the P. So when you see the JP's product pick text go by, the J and the P are kind of fancy, and those are just custom built pixel art, essentially, with this little 5x8 byte code for which of the little dots are lit up, what pattern is lit up. There's a really nice generator, I believe, if you look in the main guide. Actually, let me bring that Learn guide back up. If you look in this guide, under, I think, the CircuitPython usage, it's probably also listed in the Arduino usage, but this is the one I was looking at. You'll find is it in here? Oh, it might be in the docs. Yeah, I might have gone to the read the docs to find. There's a link to a website that lets you do character LCD pixel art, and it outputs the byte code that you need for it. So yeah, if you look into the library, look at the read the docs on this. That's where you'll find that, and maybe I'll go to that at the end. So back to the code here. So yeah, I'm creating these arrays that are these special characters. Here's where I've actually cast them into 3 of the 8 available memory slots on the driver board. So create char, and then I'm putting it in a location, 0, 1, and 2, and which pattern, char J, char P, char invader. And then if you take a look at the main code here, this is just kind of this little attract loop thing I have going here. It's just not optimized code, but it's just doing what you see. So first thing that happens, I turn off blink and I turn off cursor. I clear the screen. I set the cursor to the home position, 0, 0. Then I write out this message, which has the fancy J, the fancy P, apostrophe S product pick. So that's that first line. Then I set the cursor in a specific position. So you can move the cursor around. Here I'm saying 4 over, 1 line down. Then I'm saying of the week. Wait a little bit, move the cursor. I don't know why I moved that cursor actually. Clear it, write a different message. That's that little Space Invader. I'm using the LCD move right command to move the little Space Invader guy across. Clear it, go back to the home, and then I'm writing a different message and using the move left to sort of scroll that across. So this is real simple. This is based just on some of the example code that you can find there, nothing all that fancy. But out of stubbornness, let me see if the code still exists on the other Cutie Pie and see if we can get that to work. Oh, by the way, that was not going to work with the STEMMA QT rotary encoder unplugged. I'm sure it was having a I2C bus error trying to find that. Let's see if that just some unplugging and replugging fixes things or not. And let me try to see if I can open the code for this one. Ooh. Okay, good sign. The code still exists. Let me repoint my window at that. Okay. So here you can see, oh, the demo came up. Okay, that's good. I won't mess with that other one for a moment. So here you can see I'm able to do the same sort of stuff. I've set up the display this time as 16 by 2. And then in my main loop, after I have already drawn what I'm going to draw, so I have these little custom Adafruit flowers and then the message Adafruit LCD 16 by 2. Then the main loop here is just using the rotary encoder to change the LCD move right and move left. So that command, lcd.moveRight, just moves you one character over to the right. You can go right off the screen, it doesn't mind. And I think I didn't set any limits, so I could keep scrolling for a mile over that way if I want, but I'm going to have to unscroll to bring it back over here. And then I set that encoder, to be a better demo if you could see. So here's me moving that encoder to move the text around, and then I can click that to turn the backlight on and off. If we boost that exposure, you can see the text is still there. That's exactly what it looks like. Just normally we're shining through with that blue backlight there. All right, so let me know if anyone's got questions in the chats. I'll check those out. Mike P says, curious, would the code be able to determine which LCD is connected automatically, big screen versus small screen? Not that I'm aware of, no. I don't know that there's any way for the driver board to know what's plugged into it. It's just talking to some pins. Maybe, but I don't think I know of a way. Yeah, and thanks DJ Devon3. Let me bring up the Discord here. He pointed out there's the 3 URLs, so these are 3 separate things. If you just buy the driver board, it's a neat driver board, but it won't do anything for you without a display. Actually, that's not quite true. You can use it to drive other things if you want to. Could be just any general I/O expansion that you want. But it's with the libraries, it's designed for these displays. So pick up one of these displays per backpack that you get. Or you can, like I said, you can use some of the other displays. I just broke it. But let me try it again. So I'm going to carefully power down the Cutie Pie, unplug one LCD, I'll plug in the other LCD. That looks good. Pick up the USB cable that fell to the floor. And let's just see. Let's give it a moment. I won't rush to any assumptions. I think this one did take a little while to start when that blue one came up a moment ago. Yep, there it is. Not sure why it's taken that long. I think I was just being impatient before. So here you can see the, this is one of the RGB LEDs. This one is a positive display, not the negative type. But same code running on it. The board doesn't know that that's any different. Here you can, these are better for if you're going to turn off your backlight. These ones are easier to see, these positive versus the inverted displays. And then due to some good luck and the way that this is arranged, you can safely jumper some of those red, green, blue diodes. So here you can see this is straight red, and then I'm sort of mixing in a little bit of the green by jumpering those. So you could, I don't have a cable that'll do it, you could bring in some of the blue instead, you could go for all of them. But like I said, there's not a direct way to control RGB from this backpack. So it's all shenanigans and hooking up to pins there if you want to do that. So, and it's a subtle difference, this one going from red to yellow-ish. So that's an example of one of the other displays working. They will work, but our ideal displays are, and the ones that you're going to get the nice big discount on today, are these blue ones. Yeah, this one's just taking a long time to boot up, and that's who are you? ESP32S2 Cutie Pie. I don't know why that's taking so long to start up. I don't think the other one does. Let's check. The other one's an RP2040. Let's do a very casual experiment here. This is seeming like, I'm going to say 20 seconds for this one to boot up here. Oh, I know why. It's trying to get on my network, isn't it? It might be trying to get on my network. I can't believe it can, actually, because it's set up for a network that's in a different building. So that's what that is. Yeah, so watch, here's the much simpler RP2040 that is not trying to jump onto my network, like I think that maybe that ESP32 is. Boom, it's up and running, so that's nice and fast. Okay, I think mystery may be solved there as to what was happening. Okay, so that is it right there. That is my product pick of the week this week. It is the LCD character backpack driver and 16 by 2 and 20 by 4 LCD displays. Let's go ahead and bag up at least one of these things and put it back on the rack. And let me get the name fully right, because that'll be a lot easier when I make this into one nice, neat YouTube video later. What's this guy's name exactly? There it is. It's written on it, isn't it? That's my product pick of the week this week. It is the LCD character backpack with I2C and SPI and STEMMA QT connectors. All right, thanks everyone for stopping by today. Just a reminder, you don't need a coupon code or anything. If you want to go and grab any of these, head on over to the main site. The discounts are automatically applied. And we have products 292 is the backpack, 181 is the 16 by 2 display, and 198 is the 20 by 4 display. All right, thanks everyone so much for stopping by today. For Adafruit Industries, I'm John Park, and this has been JP's Product Pick of the Week. Bye-bye.